Welcome back, metric students. So we're talking about Chapter 10, which is all about experiments. And in particular, we're focusing on the problem of non-compliance. This is the idea that your subject has been put in a treatment or control group, and for one reason or another, they do not comply with that treatment, meaning they don't receive the treatment when they're in the treatment group, or they actually are in the control group but receive the treatment. That's the idea of non-compliance. What I'm going to do in this lecture is walk through the numerical example that goes with the handout. So if you haven't yet on your own tried to work through that example, I would really advocate that you stop the video now, try to work through getting those coefficients in that example prior to watching this lecture. In the worksheet that I gave you, it included made-up data on different houses and whether they were in the treatment or control group, whether the conversation happened and the treatment was delivered, and then the outcome variable was voted, whether the individual that we were trying to get awareness and raise awareness and get them out to vote, whether that action actually happened. So the first thing we're going to do in your worksheet is we're going to calculate the coefficients here. So for ordinary least squares, what we have is that voted is going to be our beta 0 OLS plus our beta 1 OLS. This is just a binary regression with one explanatory variable, and that explanatory variable is delivered. And so all we need to do is look at the difference in the average of vote to calculate our beta 1 and beta 0 hat for the ordinary least squared. So when delivered equals 1, there are 6 values where delivered equals 1, where there was an actual conversation. Of those 6, 5 of them. So the average vote when delivered equals 1, 5 of them actually voted. And this is beta 0 plus beta 1. The average when there was no conversation, there were 14 of those. 4 of them actually voted. This is beta 0. It's your intercept. It's your value for voted, or expected value for voted, when the delivery and the conversation does not happen. Beta 1 hat is just the difference between those, and our OLS value of beta 1 hat is going to be approximately 0.548. We know that this ordinary least squares regression isn't necessarily capturing the causal impact because while the targeting was randomly assigned, there could be something going on with the actual delivery where that's not being randomly assigned. So this could potentially be a biased estimate. The next thing we're going to look at is the intention to treat. The idea here is, was the particular household targeted? So again, our outcome is voted, and it is going to be our beta 0 intention to treat plus beta 1 intention to treat And the important thing is our x variable is no longer going to be having the conversation, but simply being assigned as a target randomly in our treatment group. So our x variable is assigned. So we're going to look at the impact of simply having assignment here. If we do the math again, if we look at the average for the vote, given assigned equals 1, there were 10 households that were assigned to be in the treatment group. Of those 10 households, 5 of them voted. We can look at the average vote given assigned equals 0. Again, there's also 10 households in the control group, 4 of them voted. This here is beta 0 plus beta 1. In the control group, that's just beta 0. So our beta 1 intention to treat, the impact of being in the treatment group is simply the difference between these two, or 1/10. Simply being assigned in the treatment group raises the expected voter turnout by 1/10. So we've looked at the OLS regression of delivered, unvoted. We've looked at the impact of being assigned to the treatment group on delivered. We got very different estimates. That's fine, that's expected. So what we're going to think about now is, all right, neither of these are quite getting at what we want. We know that the OLS estimate is biased because of those confounding factors. We know that the intention to treat estimate isn't quite getting at the impact of the conversation because we didn't talk to all these people. We didn't talk to all 10 of the households that were in the treatment group. There wasn't 100% compliance. And in fact, we talked to some households that were in the control group according to our data. So the rules for an instrument are twofold. An instrument needs to satisfy 2 criteria. The inclusion criteria meaning it has to be related to the x variable, that's the potentially endogenous one. Covariance of z and x can't be 0. That's testable, we can check that. And the exclusion criteria, it can't be related to that other stuff that impacts our y variable. Can't suffer from the same problem that x did. Now, if we think about the assignment as a potential instrument variable, it should be fairly easy to see why the assignment satisfies both of these criteria. Unless there's something very odd going on, your assignment should hopefully impact whether or not the household gets treated. Because our assignment is random, it should also satisfy the exclusion criteria. So the assignment variable is a candidate for a very good instrument variable. So we are going to instrument for delivery with assignment. So we're going to say what impact does being assigned to the treatment group have on actually having a conversation. So the regression in our first stage that we're going to look at is what is that impact? So delivered is now our outcome variable. And we're seeing how assigned impacts that. Now again, we can do this by hand because we're just doing averages here. What is the average for delivered when assigned equals 1? If we do the math, there were 10 that were assigned, 4 of them were actually delivered. Again, this is delta 0 plus delta 1. What is the average delivered when assigned? It's 0 when you're in the control group. We would hope that this would be 0. It is not. 2 of our 10 people actually ended up having conversations even though they were in the control group. This is delta 0. So delta 1 is the difference between these. In other words, we're able to increase our contacts by 2. By being in the assigned into the treatment group, we talk to 2 more households than we would have been had they been in the control group. So for every 10 households, we talk to 2 more. Now let's think through the mechanisms of what's happening here. Because what we're going to end up doing is doing the second stage. We're not going to do that regression by hand. You could throw it into Stata if you want. But I want to kind of give you the idea of where the estimate is going to go and where it's going to come from. So in our second stage regression, we're using the fact that we have these predicted values for how much of a conversation that we're going to have. We're eliminating the variation that's coming from your individual desire to have a conversation, and we're only looking at variation that is coming from being assigned to this treatment and control group. That's one way to look at it. Another way is we talk to 2 extra households, or for every household that we are targeting, 20% of them are actually having a conversation. Okay, hold that in your head. For every 10 households that we target, we are actually getting 1 extra to vote, being in the treatment group versus the control group. Now if you target 10 households, you talk to 2 more, that's what this is saying, and 1 of those votes, the impact is a 50% impact. It's half of the people that you're actually, the new people that you're talking to. This is capturing how many extra people we're talking to. Half of those are being talked to. So the second stage, we can actually mathematically show that our 2-stage least squares estimate is going to be our intention to treat estimate divided by our delta 1. And that is 1/2. So for every household that you end up talking to as a result of a random assignment, you will get half a household to vote. So according to this made-up study, it's a very effective method. Now, the policy question may differ in terms of which one of these is important, right? Perhaps the question is, how many houses do we need to target to get 1,000 extra votes? That's a question that is best answered by our intention to treat. If the question is, how many do we need to target, that is an intention to treat question. If the question is, how many conversations do we need to have, that is answered by our 2-stage least squared question. So hopefully you can see how these kind of fit together. The ordinary least squared method is just looking at the difference in averages. It doesn't take into consideration the fact that there could potentially be endogeneity. The 2-stage least squared approach gets around that by using assignment as an instrument for the variable we're interested in, which is delivery. Thank you very much for watching. I hope you're doing well, and I hope to see you soon. Please leave questions up on Moodle or shoot me an email. And take care.